All right, so what I want to go over today is a practical application of calculus. So we're going to use calculus to solve this business problem. So the problem is as follows. A management company is going to build a new apartment complex. They know that if the complex contains X apartments, the maintenance costs for the building, landscaping, etc. will be C of X equals 4,000 plus 14X minus 0.04X squared. The land they have purchased can hold a complex of at most 500 apartments. How many apartments should the complex have in order to minimize the maintenance costs? So they have a maintenance cost function that's represented by this equation right here. And what we're trying to do is we want to minimize the cost of the maintenance costs. So we want to minimize this function right here. And we also know that the land that they have purchased can hold a complex of at most 500 apartments. So we know that X has to be less than or equal to 500, but we also know that X has to be greater than or equal to 0 because you can't have less than 0 apartments. So basically, they have to build a complex with something between 0 or 500 apartments, and we want to figure out what number of apartments they have to build to minimize this cost function right here. So if we just look at a graph of the function, it looks something like this. So you have 0 right here, and you have 0.4x squared, and that's going to determine what the graph looks like. So it's negative, so I know it's going to turn, or it's going to open up downwards, and then also it has an x squared, so I know it's going to look like a parabola. So it looks something like this. So all we need to do is we need to evaluate the function at 0 because that's the minimum number of apartments that can be built in this complex. We need to evaluate at 500 because that's the maximum number of apartments that can be built in this complex. And then we have to also evaluate the cost function at the maximum of this function. So basically what we're trying to do is we're trying to figure out, and we're restricting the number of apartments to 0. It has to be in between 0 or 500. So we want to evaluate at 0, we want to evaluate at 500, and we want to evaluate it right here. And this is a critical point. A critical point is where the derivative of the function equals 0. So first we want to figure out at what number of apartments does the derivative of this function equal 0? And what the derivative is it's the slope of a line that's tangent to this function. So basically what that means is if you have a function that's going at this point, it's like this, you want to figure out at what value of x is this derivative 0. And you can tell that 0 because it's just a slope, rise over run. So y is not changing. There's no rise. It's 0. So that's going to make the derivative 0. So how to find the derivative of this function would be you have c of x equals 4,000 plus 14x minus 0.04x squared. So how to find the derivative of a function is you can take the derivative of each individual part of the function and then add it up. So how to write the derivative is c prime of x. So we have c prime of x equals, now the derivative of a constant, so this is just a constant number, 4,000 is always going to be 0. So that's 0. The derivative of 14x is just the constant that's in front of x, so it's just going to be 14. Now we're going to want to do minus. The derivative of 0.04x squared is going to be 2. So you bring this power down, you multiply it times that constant, which is 0.04, and then you still have an x remaining, and the x is always raised to its original power minus 1. So 2 minus 1 is just x to the first power. So the derivative of this function is going to be 14 minus 2 times 0.04, which is 0.08, times x. So now we want that to be equal to 0 because that's the critical point of this function, which is right here. So that's just where the derivative is equal to 0. And then we want to solve for x and figure out what x equals. So to solve for x, you can just add 0.008x to both sides. So you got 0.008x equal to 14. Divide both sides by 0.008 because you want to get x by itself. And then you get x equals 175. And that's apartments. So the point right here is going to be 175. So all we want to do is we want to evaluate the cost function at 0 apartments, at 175 apartments, at 500 apartments. And we want to see what gives you the minimum number because you're trying to minimize that cost function. So let's do it. So the cost at 0 apartments is equal to 4,000 plus 14 times 0. So I'm just plugging it into the original cost function, minus 0.004 times 0 squared. So that equals 4,000. So C of 175, do the same thing. We're plugging in 175 into our original cost function. So you got 4,000 plus 14 times 175 minus 0.04 times 175 squared. So that equals 5225. And then you have C at 500, which equals, so same math, plugging in 500 into the original cost function, you're going to get that equals 1,000. So now comparing these, you see that when the number of apartments equals 500, the function is minimized. So the answer to this question would be, how many apartments should the complex have in order to minimize the maintenance costs? It would be 500 apartments need to be built to minimize this function. And if you look at this function, it makes sense because we're restricting it from 0 to 500. So there's not a point that's lower on this graph than when x equals 500 that resides inside these boundaries from 0 to 500. So at 0, you have the maintenance cost to be 4,000, and then the maintenance cost is going to be higher at 175, but when you go back down to 500, the maximum number of apartments that can be built, that's when the maintenance cost function is minimized. So answer is 500 apartments to minimize the maintenance cost function. And that's how you solve this problem.